Okay, so Terraform is about the Terraform here. I'm quickly going to take you through the Terraform ride. Okay, next say 5 minutes quickly what all is there in Terraform. So Terraform, we have got hundreds of cloud provider. Okay, and we have got multiple resources under these cloud providers which you can manage it using the Terraform, using as a infrastructure provisioning tool. There are multiple resources, so each, say your AWS or Azure or OCI, each has got the compute instance available, right, which you say it by other names. So in or say the network in Azure you say it VNet, in Oracle you say it VCN, virtual cloud network, in Azure, in AWS you say it VPC, virtual private network, virtual private cloud, VPC, right? So that way you have got the same thing in the cloud but having other names, but each of these is known as the resource. Okay, you have got say network, VCP. So VNet, okay, VNet has got multiple things involved in it. It has got the security list, it has got say the routing tables, it has got various other components, the gateways are there. So these are like all resources which are available in the cloud providers. So Terraform has got access to all these resources, and these resources interact via API. So we are going to see how Terraform works as well in a while. Okay, now Terraform works basically with the configuration file, which is one of the input to the you are giving it to your cloud provider. Okay, like in this Terraform configuration files, you are defining the state, what you want to achieve. Okay, the desired state of your uh, infrastructure you want to achieve. That is what you are going to maintain and communicate it to the Terraform via these configuration files. Then it has got various types of variables which you can use it to configure your resource. The using these variables, you can basically make your code robust and dynamic as well. Then it has got the state file. So this is the heart of the Terraform, which basically maintains the state of your infrastructure. Okay, whatever you have created, it will be recorded in the state file. Later on, whenever you are making changes or you are again creating a similar kind of infrastructure, it is going to check the current state of your infrastructure and then will be proceeding further. Then you have got the data sources. Like suppose I have created one network on my own via console, not via Terraform. I want to deploy some compute machines in that, so I can use that as a data source, and it is going to give me the required information that whatever the subnet is there, or public or private type, whatever it is, that information I can use it, and that is I can gain it via Terraform, via data source. Then I can write modules on my own, which I can reuse it multiple times. Okay, like deployment of network, or creation of virtual machine, or creation of storage. I can write code once and can reuse that code multiple times. I can call that modules. Okay, so it is similar to your functions in your programming language, which you can call the function and can use it. That is what it is, module. And there are modules which are created by vendors as well, or you can create your own modules too. Then you have got workspaces is like the best. Like I want to, with the single code, how I can manage multiple instances, say production, dev and test, all three I want to manage. The single code, how I can use the same code and use it and optimize my coding, and to to manage the entire instance strategy of my organization. Okay, so that is via workspace. This is a very beautiful concept in Terraform. We are going to talk about it in detail. Then provisioners. After installing the infrastructure, okay, I want to deploy some applications over it. That is how I can do it with the provisioners. Security. whatever, wherever possible, I don't want to pass the sensitive information, the logins, the everything, eh, in the file or so. So what are the security aspects? What are the best practices I can follow on the security? Then the Terraform Enterprise. Individually, you are working on the, say, your cloud accounts. That is fine. But what about like if you want to use the Terraform within your team? Okay, where 2 or 3 people are, at the same time making changes in the code, how you can control that thing? Okay, so that is via Terraform Enterprise. We are going to talk about it in detail about it in one of the session. Then we are going to talk the overall best practices of Terraform as well. So that is what, we are going to see everything in Terraform. So Terraform is basically a centralized open source tool. So Terraform is basically the open source tool which is available. Okay, and the important thing is the same Terraform tool gets integrated with all the cloud providers. Okay, there is no separate configuration or separate thing is there. Same is going to be with any cloud provider you can connect, and you need to give your all the inputs in the form of configuration files, which you are seeing it here. All these configurations are basically the desired state you want, and the current state is maintained in the state file, the terraform.state, which you are seeing it in purple. And then it gets connected with whatever cloud provider details you have given. So this is the high level overview of Terraform. So Terraform is an open source infrastructure provisioning tool. It is written in Go language. Okay, and the configuration files where you are going to give an input. Okay, that will be in the HashiCorp configuration language, HCL, which is pretty easy, straightforward, not much complicated. Or if you are say having working on the JSON format or JSON language, you are comfortable, you can even use that. So that is fine. In both the languages, you can write down the code. You can use this for building, for changing, for versioning your infrastructure. Okay, so whatever the infrastructure you are going to create, and whatever the services along with that is required, the dependencies and all, that is all taken care by the Terraform. So whatever components you wanted, even the default or anything, everything is managed and maintained by the Terraform. Okay, now there are some cloud native tools as well which are available. So each cloud vendor has got its own tool. Like if I say talk about the Amazon, it has got the AWS CloudFormation. Then if I say talk about the Microsoft Azure, it has got the Microsoft Azure Resource Manager, ARM. Okay, then if we say talk about the Google Cloud, okay, it has got the Google Cloud Deployment Manager. Now these are like the cloud native tools. Okay, that means AWS will be only working with the AWS cloud vendor only. ARM is going to work with Microsoft only. Google Cloud Deployment Manager, it is going to work with Google Cloud only. Okay, so these are like the cloud native tools which are developed for the cloud vendors itself. Okay, but if we come to the Terraform, so Terraform is the cloud agonist tool. That means it works with all the cloud vendors, all the cloud providers. Whichever cloud provider you can think of, it works with all the cloud providers. Apart from that, it has also got the solutioning for the VMware, for the Kubernetes, for the PaaS services, for the databases, MySQL, whatever you can think of. It has got all the things there. So infrastructure as a service and the platform as a service is what your Terraform covers very well. Okay, and now if you want to say on the SaaS side, software as a service, if you are seeing, slowly Terraform is getting its legs into that as well. Okay, so on the SaaS model as well, now it is going to be there, but yeah, not much as of now. But on the SaaS side, like Kubernetes, you can deploy it using the Terraform. Whatever the services you wanted within the Kubernetes, the deployments and everything, creating, managing the namespaces and all, that also you can perform it using the Terraform. So Kubernetes is basically the platform as a service, right? For any cloud vendor, you can think about any cloud vendors. The Kubernetes as a service is their WebLogic, Oracle WebLogic. You can manage it using the Terraform, deploy it using the Terraform, configure it. So everything you can manage it. So this is the tool HCL. So we will be basically writing our code in HCL. Okay, that is pretty simple and easy to easy language, and all the help is available while writing the code as well. So don't worry about it. We will be using the HCL in our codes. Okay, now if I say the imperative infrastructure as a code, if I say the imperative, so let's first understand what the imperative and the declarative means. Okay, the simple example, if I say want to give you the navigation of my house, okay, like I say, okay, you come to my house, what I'm going to do, I'm going to leave my house, get into the car, will go to straight, okay, and then we'll turn the right or left or whatever it is, and then I will be reaching to my house. Okay, that means how I have to reach to the destination, that complete path needs to be defined. That is what the imperative means, which deals with how you are going to attain the end result. Okay, so it basically, if I talk about from the infrastructure point of view, it focuses on actual provisioning process, that how the provisioning is done. Okay, and via that it might need some input, some file, some configuration, you need to point it out. Okay, how you need to get the state, that you have to define it. What the declarative means is, which basically just focus on the end state. Like I want to reach home, okay, you just give me the address and I'm going to reach. Now how I am going to reach, the closest path, or how I am going to follow, that you leave it to me. Okay, you don't worry about it, you just give me the address, and that is the location I have to reach, and that is the desired end state. Okay, so here the declarative code basically focuses on how you are going to get what is the end state you want. Now how you are going to get it, that is your problem, you need to find it out. Okay, you need to check on the interpretation engine or what configuration is required, or so you just check it from your end. We are not going to give any input there. Okay, now Terraform basically is the declarative language. Okay, you just give the end result, that this is my desired state, which you are going to define it in the configuration file, and it is going to get that state. Now how it is going to get that state is none of your business. Okay, you don't have to give that detail. Terraform will automatically identify it. Okay, with the help of vendors, the plugins and all, it has got that intelligence inbuilt, that how to reach to that desired state is all on its own. Okay, so that is what the Terraform is, the declarative language. Terraform is basically it follows the declarative concept and defines only, you are going to define only the desired state, what you need. Other than that, you don't have to give any input. Like I need to create 6 virtual machine, then you are just going to give the count, that okay, I need 6, and this is what the version of the machine I needed. AMI you are going to give it and leave it. It is going to create 6 virtual machine on its own. It is going to create a default VCN. It is going to create everything. Okay, the network and all. If I say talk about the AWS, if I say go on to the Azure side, in Azure you need to first define the network and all. That is the cloud vendor specific thing, right? Where you need to define the vendor, you need to define the network, the subnet, and then you are going to deploy it. There is no default thing exists there. So that is the cloud vendor thing, but you don't need to give an input to the vendor in your code, that what you need it. You are just going to say that okay, I need this state, this state, this state, and you are going to get it. Okay, now this is the very important concept of mutable and immutable infrastructure. Okay, just if you see this diagram, the first one, okay, let's see this. I have got an OS of version 1.0. Okay, and over that I have an application which is running, say, version 1.0. Now I have a requirement in which I have to say upgrade my application to 1.1. Okay, so what I'm going to do is I'm going to make this changes here. Okay, we'll install this, and then a reboot might be needed, and then a reboot is there, and then I will be getting the 1.1. So I have done all the changes here and then reboot it, and this is going to give me 1.1 here. Okay, now this is the mutable infrastructure. Okay, now what mutable infrastructure is, that means it is the infrastructure where you are not creating the infrastructure from the scratch. It is the changeable infrastructure thing. Now what is in the second case, if you see, for just getting the version 1.1 instance A, I have provisioned the new infrastructure and gone with 1.1. Okay, and then have destroyed this instances. So altogether I have done the instance B. If you see, the instance B has been, say, I have generated it from the golden image, some golden image I have created it in, and kept it. Using that I have created the machine image and provisioned it, and then I have destroyed the instance A. Now what benefit you are going to see here? Immutable, you are creating it from the scratch. This is altogether the new version, and we are not worried about the compatibility. And here you can see there is no downtime was also required. Okay, here we have to reboot it, and that is associated with the downtime, right? But here if you see, there is no downtime required. So we have just done the instance replacement with an well architect immutable pattern. Okay, we can create multiple instances, or we can whatever the services are there, we can use it for the multiple instances as well. So even in the mutable, this thing A is not replaced. Okay, but you need to check for the compatibility. Maybe your 1.1 application is not compatible with OS 1.0. You might need some packages over it. Okay, and that is where it is leading you towards the configuration drift. Here you are going to see the phenomenon of configuration drift, where suppose this is version 1, I need version 1.1, but it might not having a compatibility after doing all the deployment and everything. That is a tedious job. Okay, and it might not be compatible. So I might here end up with, say, 1.001 or 1.002 version in between, but I might not get 1.1 directly here, because there might be some incompatibility or something is there. But here in this case, whatever I am doing to doing it from the scratch and deploying it, it is going to be, I'm going to give the compatible version and the stable infrastructure. Okay, no configuration drift or anything is there. Okay, even though if this requires the new machine or something, I can create it from the scratch and give that version directly. I don't have to spend time or in troubleshooting or with the incompatibilities or anything there. Okay, so version 1.0 to version 1.1 is directly done on the new infrastructure, and all the configurations and everything are well intact there. And Terraform basically works on that. And if you see, even all the cloud things are basically towards an immutable infrastructure only. Whenever you are creating a new virtual machine, you get it from the image which has been regularly updated by Oracle, right? Maybe the Linux, you are going to see the 7.1, 7.2, 7.3. Okay, through the kettle versus pets. So in case, if anything, like for the kettles, if any issue is there to your one of the kettle which is there, the thing is, you are not going to troubleshoot that. Okay, the cult is the only option, otherwise it is going to infect others. Okay, but if it is, say, something happened to your pet, you are going to take that pet to doctor and go for doing the vaccination or anything, whatever is required there, right? So pet versus cult is what the immutable and the mutable infrastructure directly links with. Okay, but there are many other benefits as well. Now if you see, your operations are simplified with an immutable infrastructure. Your continuous deployments will be there. Okay, there will be very less failures because you are already taking care of the compatibilities. Your error mitigation and even the threats, like if your infrastructure is running for a long time, there might be some threats might be there, okay, which you might not be able to rectify it, okay, or might not be able to catch it as well. Okay, if you have recently observed that WebLogic issue worldwide was there, the vulnerability that was so so worst, my almost 6 or 7 instances, customer instances, were affected with that, and it was hacked, and some cron script was configured on the server, which was eating my 400% of CPUs. So my any WebLogic deployment was not coming up. Okay, so when you are, say, regularly creating the infrastructure, you are seeing the logs and everything there, it is going to get it into the logs, and if any vulnerability or anything is there, you are going to rectify that then and there itself. Okay, so the same thing, if there, what we did is, like, Oracle has created the new version of WebLogic with that vulnerability patch already. We have created with that, and that might have given us a new safe instance, with the new say golden image we have created. Otherwise, we have to go ahead and check all the instances. We were maintaining around 16 to 17 instances. Out of that, 7 were affected, and we finally manually have rectified it and applied the patch. Some versions were different, so some WebLogic versions were different, so the compatible patch was there. So there, that was a classic example of immutable and the mutable infrastructure. We didn't make any changes there, but yes, the compatibility and everything, some patches were not even compatible with WebLogic, okay, because there were some dependencies required. Otherwise, we would have created a new instance and then gone with the deployment. Anyhow, WebLogic base always remains the same. Okay, and then you go ahead and perform the deployments over it. So that is where your mutable and the immutable infrastructure comes. So it has got its own benefit. It also reduces the cost as well, as you are performing and creating the instances from the scratch. With you can reduce the size of the VM while creating the instances with the image. Okay, maybe first phase it was not utilizing it. The second phase onwards, you have deployed it with a lower infrastructure, right? So here is another classic example which you can see here, that my app is 1.0. Okay, and here you can see some of the services I have updated it to 1.1. Some I have downgraded it as well, maybe because of the compatibility or so. So I can see the configuration drift is there. Okay, all are not at the same place. With time this happens. Okay, I have applied some patches to something or so, but here if you see in the immutable, I have just decommissioned it and created one with app 2.0. So my everything remains intact at all the same level. So there is no configuration drift there, and this is the methodology which is being used nowadays with all the cloud providers. Means they are on the same line of concept, where they are giving you the pre-installed image or something, and then so there is a very classic comparison of this as well. I don't know whether you have gone through that, or sometime you have come across to that or not. AWS has started that delivering the frozen pizza model. Earlier it was known as. So in the frozen pizza model, what they do is they have got the golden image, which has got the database server, app server, web server, and everything, and they just deliver it when as and when required. But what happens is that image might be created long back, so it might not be having all the things updated. Okay, or maybe the code deployment on that might be the not the latest one, because they have packed everything. So that is a frozen pizza model. You can just put it in the deep freeze, take it out, reheat, and give it. Okay, so they have then shifted to frozen base pizza model, in which what they do is the stack they have created, predefined, but code deployment every time they do it on their own, means the latest one. So that has solved that problem. But there might be some, OS vulnerabilities or something might be there, the version might be the latest there. So they have now shifted, the made to order pizza model, which basically as and when required, they are going to create the technology stack as well with the latest image, deploy the new code and give it. So that is more like an immutable infrastructure. Whenever you need it, you create the fresh one with the new image, deploy it, and give it to your team. So that is going to, not having the configuration drift also, you can manage it. Right. So this is about it. So this is, the benefit of Terraform compared to other configuration language. I saw some question like how Terraform is better than Ansible, or how Terraform is better than other IAC tools, especially from the provisioning point of view. Then this is what reason is. So it has got the immutable infrastructure creation methodology. Whenever is needed, you just destroy it and create it. Of course, you need to basically maintain your data thing and all separate. So right from the beginning, you have to follow that strategy, that you are keeping your data separate, and your web application and the infrastructure deployment on the web, web deployment on the application part separate, so that whenever is required, you can create the new version and integrate it easily. Okay, and there that frequency of creation of the new infrastructure might be might be different. Like suppose if it is a networking thing, the DNS or so, you can recreate it on the weekly basis, the infrastructure. But suppose if it is something like the batch job or something, that you can do it on demand. Okay, when as and when required, anybody is requesting it, then based on that you can have a strategy and create it. So Terraform is basically, uh, you know, uses the push methodology. It is the masterless and the agentless. That means there is no master server, there is no agent installed. Terraform, it is very simple. You can configure it, do the setup. There is no centralized GUI or something there for the Terraform, but yes, everything you can manage it from, say, some tools are there through which you can go through the coding, the Visual Studio Code and all, and you can manage those stuff there. Okay, for the Terraform Enterprise, yes, there is a GUI there. You can log in and you can see, the locking thing and all that we are going to cover it. But yes, so Terraform, there is no, agents or anything is involved in that. It's pretty simple, just simple configure it and start using it. Okay, so Terraform, in the Terraform, basically it all works on the state. Everything is managed under the state, and the state file is become like in Terraform becomes very important file for from the infrastructure point of view, from the migration point of view, or for importing point of view as well. So everything everything is in the state file. So whatever the changes you are doing it in the configuration file and executing it, it is going to affect the state, it is going to change the state. So all the dependencies, everything, when the Terraform is run, it is maintaining the dependencies inbuilt and maintains that. Okay, so the Terraform graph is prepared. We are going to see the architecture of Terraform in the second module. Then you will be able to clearly understand that, okay, how the, what are the components of Terraform and how it basically works. So this state file is basically going to have all your resource state, whatever is the state of your resources within your cloud provider, and which you are maintaining it via Terraform. And if you want to alter it, if you want to change it, how this state is going to get affect, and the latest state is always saved. So this state file, you can even maintain it on the your local machines, or even you can maintain it on the centralized server. So both the options are there. Remotely also you can manage and maintain the state file. We are also going to see that when we are going to cover the Terraform state management. In that we are going to see how we can manage the Terraform state file centrally. And as we know that state is going to manage all the changes or all the state of your infrastructure. If there is any change there, then again your version controlling also comes into picture. Whenever there is a change, the new version of the state file is well maintained. So we will also go through some scenario, like if you have lost the state file, what option is there for you to recover it? Okay, or what are the options there to regenerate it? So that also we are going to see in the state management session, how we can maintain that.
So guys, I hope you really liked our session, and if you have any kinds of doubts, you can please comment down below and our team will reach out to you. And if you're somebody completely new, then you don't have to worry because we have got your back. We have properly planned our 7-week roadmap so that you can excel in your examination. Week 1 would be about what and why about Terraform. We'll be discussing about Terraform installation and basics in week 1 as well. Week 2 would be read, generate and modify the configuration. Week 3 would consist of provisioners, loops, data source and built-in functions along with workflow and state management. Under week 4, we'll be discussing about modules and workspaces along with Terraform CLI and security in Terraform. Week 5 will be more about Terraform Cloud and enterprise capabilities. Week 6 would be exam registration and some amazing practice questions. You'll be having 5 practice tests that will let you check your knowledge. And week 7 would be tips and resources for clearing the exam certification, CV preparation, and the most important part is our on-job support. And if you're somebody who's completely new and you want to study the exam content from start to finish, then please check out our free class at k21academy.com/terraform02. Under this free class, we'll be covering a lot of topics like cloud and DevOps overview, cloud automation tools, Terraform, CloudFormation, Ansible, Chef, Puppet, infrastructure, automation, IAC, Terraform for beginners, what, why, and who should be learning Terraform certification, extending Terraform with Ansible, Chef, Puppet, etc. We'll be giving you a demo of VM deployment in AWS Cloud using Terraform. And the best part is we'll be covering a lot of job opportunities and how you can get better pay in your Terraform job. So all you have to do is just log on to k21academy.com/terraform02 and click on book your free seat now. Select your event date when you're available. Moving ahead, add your name, your email address, your phone number, and click on yes, proceed ahead. Now you'll be seeing this kind of link at the extreme right. Save this link, add it to your calendars, and I'll see you in the free class. Till then, take care and keep learning.